All right, let's continue. We all had our break. So when you're exiting, you want to leave the lab in the same condition that you found it. So don't leave wet rags lying around or puddles of unknown liquids on countertops and things like that. That's not a good thing. You want to clean up after yourself properly. You want to store your wafers on the designated shelves and areas. You got to clean all your beakers and put them away. You want to degown in the degowning room in the reverse order of gowning. Okay, get rid of the disposable stuff, which is what? The hairnets, the face masks. You guys will be throwing them away because after you're in the clean room, you won't be coming back. Your booties. If you're going to work for a while at the clean room, you know, we encourage you to put them in one of the cubby holes and reuse them a couple of times before you throw them away. So we're a little bit greener, but Harold will instruct you on that. You want to hang up your smock, don't leave it on the floor. Put away your safety glasses in the safety glass cabinet. Now that cabinet has an ultraviolet light in it that's turned on every day. The ultraviolet light kills bacteria, okay? And that's the way of sterilizing the safety glasses. You can also wipe them down with IPA and water. A lot of people like to clean them because sometimes they look a little foggy. So I encourage you to do that if you want. And the whole purpose for the ultraviolet light is to sterilize them because there's only one thing that I know of that's transferable through safety glass, and that's pink eye. That's always a risk, right? So that's why we do that. Okay. If there's an emergency, you want to get out of the fab the most direct route possible. You've got to turn off all the hot plates if it's possible. Now, if there's a big fire where the CO2 is, spewing out CO2, you need to get out quickly, then you just get out. If it's just an alarm and you don't see or smell smoke, you can go ahead and turn off the hot plates and the processes and get out. Now, you guys won't have to worry about that for this class, but later on you'll be doing more and more stuff. So, and you'll have to turn off the hot plates if you're like an intern or something for one of the companies in the cleanup. Get your partner and other lab members out as soon as possible. So if you hear an alarm, tell other people that there's an alarm, right? Get out of the fab. If there's an active fire alarm, if the alarms are going off, it's already calling 911. The firemen will meet you as you're going out the door. They're really fast. Every once in a while we have a sensor go bad, and we get the emergency response team from Albuquerque Fire Department come, and they're already putting on their chemical gear sometimes. Depends what the alarm is. So yeah, that'll automatically call for you. You want to meet in front of the parking garage at Basehart and Bradbury, okay, at that corner. Why do we have a meeting place?
Head count.
Head count, very important. If I have 12 students in the fab and I only count 11, that means somebody was left behind. Now, if that one person who was left behind, we think, is actually at Dunkin' Donuts, okay, decided to go to his car instead of go to the assembly point, then we got to send in a fireman to go look for him. And now we're putting a person at risk, or we may not need to. Okay, so that's the main reason for the head count. You don't want to risk other people looking for you. Okay, so go to the assembly point. The other reason you go to the assembly point is a fireman or Harold or somebody might ask you, what happened? Well, X, Y, and Z happened, and they know, okay, it's not the silane, it's not the methane, it's this other thing, and then they know how to respond better. So you might see something that someone else didn't see. You might have seen the smoke coming from another piece of equipment before the whole fab was full of smoke. So you know the origin. There's certain things you might know that no one else knows. So it's another reason to go to the assembly point. Okay? If there's no alarm but you got to get out of the fab, call 911 when it's safe to do so. If it's not safe, get a safe location and contact proper response personnel. If you call 911 from inside the building, it'll call UNM police. Usually you want to call UNM police first. Okay, we already said to go meet. Okay, and then you can call the lab manager once you're safe. If someone faints or is unconscious, then you can call 911 inside the building to get UNM, and then they will get the right people to come. They know the building. If you say, I'm in the fab in the MTTC, they know where that is. If you call a regular 911, they don't know what the hell you're talking about. Okay? That's the main reason you call UNM, and they will get the right people there. Okay, if you know CPR, you can go ahead and start it. You always want to call 911 before you start CPR, or tell someone to call 911 before you start CPR. Okay, we also have these defibrillator packs. You know, you've seen those in the airports and stuff. I think every airplane now has them. It's a red box, and there's some patches in there, and you put them in a certain part of your body in the front, and they will turn on the automatic system, and it'll shock you. It'll take your pulse, see if it needs to shock you, and I think it only shocks you once. Okay? Usually that gets you going again.
With an AED, it's got sensors in there.
Yeah.
And it'll read your heartbeat. It's like a little EKG in there, and it'll tell you, you know, shock to rescue. It's got a little thing in there with the audio circuit, and well, and it'll tell you, you know, shock to rescue. And all you do is press the button.
Okay.
And then it'll again, after it shocks, it'll sense it again, and you know, shock to rescue.
I don't know how many times Harold has mentioned that it does it one time, or you're only supposed to do it one time.
Well,
but you can ask him. He's been trained on it officially.
It depends on that amount of information. Somebody makes you mad, is it okay to use that on them?
Yeah, well, then it's abuse, and you'll go to jail. Yeah, you don't play with the equipment, the safety equipment.
Like, sorry, I swear you passed out.
Don't move anybody unless there's some other danger, like fire. Right, so you leave the person there because they might need a backboard, or, you know, you never know. If you have to move someone, Harold will tell you to use the Red Cross method, which is you grab them by almost by their collar. You grab their shirt, and then you pull them along the ground to get them out of the fire or whatever. Okay? If you can, right? If you can. We have lots of fire extinguishers. We don't have a lot of different kinds, but there are a lot of different kinds of fire extinguishers in our clean room. We have the CO2 fire suppression system, which is basically a tank of carbon dioxide hooked up to sensors, and it'll spew out carbon dioxide into the solvent hood. So in the event that triggers, you want to get out of the fab because you'll run out of oxygen real fast. Make sure your buddies know about it and get them out as well. There's Halitron fire extinguishers located all over the lab. I think it's in every bay. Halitron is acceptable for flammables or electrical fire. It's a BC type fire extinguisher. Okay, there's ABC. There's also a K now. There's a kitchen fire extinguisher. If you guys didn't know that. It's for grease fires. So I think A is for flammables like wood and stuff, and then B is B. What's B? Electrical. It's in your write-up, so study that. You have to know each type.
C is for metal. Or no, one of them is for metals.
Yeah, metals. There's a metal fire.
And I think C is electrical. Well, with electrical fires, you got to cut the current off first.
If you can. But these are dry chemical fire extinguishers. This one's gas. The Halitron's a gas, and then there's dry chemical ones. But we don't use those in the clean room because they are full of particles. So they'll mess up all the equipment. So that's why they go with the Halitron. Halitron's more expensive, works just as well, but doesn't produce the particles. Okay? I need to add a slide on which one is which. Oh, here it is. What a deal. Okay, so the different types of fire extinguishers. A is for ordinary combustibles like paper, wood, cardboard, and plastics. You might have one of those, you know, if you're a carpenter or something, right? Yeah, water's good for that. That's an A type, pressurized water. B is for flammables or combustibles, like cleanroom chemicals. Acetone will burn if you put a match to it. Isopropyl alcohol will start on fire if you put a match to it, right? So those are called combustibles and flammables. And the B-type fire extinguisher is used for that. C is for electrical. Now the halotron covers B and C, which is what we'll have in the cleaner, most likely, if we have a fire. So electrical equipment, which is wiring, breakers, outlets, that sort of thing. Generally speaking, if there is something going on, Harold is going to be in the fab with us. He would probably be the first one to grab the fire extinguisher and use it. But in case, you know, he's not around and you think you can use it, go ahead. Otherwise, just get out of the cleaner.
So they carry
Don't
all
put yourself at risk, an undue risk. What?
They carry all those in there?
Well, we have the VC, which is the halotron. Okay, and then the CO2 for the solvent bench. We don't have combustible metals.
I was going to say titanium. I didn't know that was combustible.
Yep. It likes to form titanium oxide, right? So it'll burn. Sodium will burn. So we, you know, halotron will cover most of our fires, and CO2 gets the rest of them. And that's on an automatic system. Oh, you don't see that. There's CO2 on the bottom. CO2 fire suppression systems located in the solvent bench. So you'll see that on the tour. Chemical safety is a big deal. Okay? If you're working with chemicals, no matter what company or what environment you're in, they have to give you access to material safety data sheets. The most common way is with these binders. So every chemical you work with will have a material safety data sheet associated with that chemical in a binder. It is your responsibility to read that and understand it. Okay? You take just as much responsibility of your safety as the company. Now, if the company doesn't supply you with that, you can tell them, I'm not going to work with this chemical until I see an MSDS for it. And an interesting case was one of my students worked in a body shop, and they were spray painting cars all the time and using all kinds of noxious chemicals to clean things and all of that. And he had never known about an MSDS. So after
OSHA requires it.
yeah.
Anything, right?
So he asked his supervisor, look, I'm working with these solvents and stuff, and can I get some MSDSs? And the owner finally went ahead and got all the safety gear for the workers. But before that, they didn't really. I mean, people use spray paint cars. You do it in your garage, you spray paint things, but you do it once in a blue moon. If you do it every day as a job, you really need safety equipment.
Well,
And you should use it once in a blue moon too.
well, the other thing is, people think that latex paint is safe, right? And they have all these latex spray painters that you can buy for spraying your house or whatever, right? Okay, but protective equipment is still required. There's a man in Tuscaloosa, Alabama, that died because they coated his lungs and he couldn't breathe.
Yeah, so that's a good point. It's a delivery system that can be important too. If you make a fine mist of what's normally considered a pretty harmless chemical, like the latex paint example you said, you probably would want to wear a respirator, okay, or a mask, or be in a well-ventilated area. You know, you have to kind of be cognizant of it. And the material safety data sheets are really, really good. We do have a learning module on MSDSs, which I've used in the past. And I might have you go through it again. It's very useful. You know, if you're a janitor, you're going to work with all kinds of chemicals. It's probably a good idea to read the MSDSs. Nowadays, everything's online, right? Most companies provide you free of charge online. You can look it up. Hydrofluoric acid is what we're going to be working with. Okay, that's not good stuff to get on you. If you get it on you, you have to use calcium gluconate solve after you've rinsed for 15 minutes, and it absorbs the fluorine. If the fluorine gets to your bones, it can cause a lot of damage, and you can even die from HF exposure. So you will be working with HF. Okay? Report any chemical contact to the lab manager. So if you think you got some chemicals on you, let Harold know, and me, and I'll let Harold know. Make sure that you stay safe. But so far, no one's ever gotten contaminated because they follow all the directions, right? It's pretty safe if you follow directions. So you'll be wearing acid gear. Some of you, not all of you, will be doing this, but some of you will have an opportunity. Okay, you have triple trionic gloves, which are good for both caustics and solvents and acids. We have what they call an acid apron, okay, and a full face shield. All right, the trick with the face shield is you want to make sure it has a little tightening thing on the top. You want to make sure it's tight on your head, not real tight that you pass out, okay, but tight enough that if you lean over, it doesn't fall off. Okay, I mean that's a possibility, right? Think about it. You're working with an acid bench. You have to lean over the bench to see what you're doing, and if your face shield falls into the bath and splashes back, one, you don't have a face shield, and then right, so you've just caused more problems than if you didn't even have it on. So it's always important that you understand how it should be worn. And then the face shield you can flip up so you can see. Right? But you want to flip it back down when you're working in the chemicals. And Matt always has the problem of remembering to flip it down, so I would appreciate if you remind me. You know, I might do some of this for you or show you how it's done, and especially if we're pressed for time, and then you'll see, you know, hey Matt, put your face shield down, okay? So we have an acid bench for acids. What is this, sulfuric? This H2SO4 and H2O2 mixture is called Piranha. Okay, it's a really nice trade name. The guys who invented it in the semiconductor industry found that this is really good for cleaning organics off of wafers. It's also very good at cleaning organics off of bones. Okay? That's why they call it Piranha. It will burn you. It will cause tissue damage.
Charming.
Never reach into a bath with a gloved hand. You should never have to reach into the bath with a gloved hand when sulfuric or something like that. Okay, the reason you wear gloves is not to protect your hand to allow you to put it inside of a bath. It's so that in case there's a splash, it'll protect your hand. The gloves should never actually get in contact with any chemical at all. They should be dry the whole time because you're using handles and you know, and you're putting things into the bath that don't require you to actually touch the solution. Okay? So your gloves should never get any chemicals on them. Now they will get DI water because we do put the wafers into a quick dump rinser, okay, and then we turn on the deionized water, so you will get spray from the water on your hands and on your gloves. So the gloves will get wet a little bit from DI water, but you should never get any acid on it, okay?
DI water is okay.
Yeah, DI water is fine, but that you will see, you know, the gloves get wet, but it's from the DI water, hopefully.
Do you
So-
guys want afterwards?
Yeah, we always wipe everything off. So, you know, you will drip a little bit of developer and some resist onto the table as you're moving it from the developer into the DI rinse bath. That's called drag out. And then you'll get a rag, wipe it down, and then put it into the caustic can, and then we'll show a picture of that. If you spill acid or caustic on you, you have to go in the safety shower, pull the chain, and stand there for 30 minutes or until help arrives. When pouring acids and bases, always pour away from you and wear personal protective equipment. This is on the test as well. Triple trionic gloves. It's triple thick trionic gloves. Acid gown is what we call it. And the face shield, acid gown also works for solvents. And when pouring acids, always what? Pour the fluid away from you. Okay? So pour fluid away from your body in a continuous smooth stream with no gurgling. That's also on the test. Fix that problem. Okay. So you pour it away from you, right? In case something slips, it's going away from you. Okay, if you're pouring it towards you and you drop it or something slips, it's going to come towards you. So that's why you pour away from you. You don't go glug, 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 right? And then it splashes and stuff. You pour it nice and smooth. Take your time, you know? You get paid the same, right? So do it nice and smooth. Take your time. Always take your time in a clean room. Don't gurgle. No gurgling. No splashing. Okay, so pour it away from you. Make sure all the chemicals are in the appropriate containers with labels. Don't put mystery chemical in a mystery bucket. Okay? Gotta have a label. Alright? And if you see something in the clean room that's not labeled, say, Harold, what's in there? Right? It should be written. They usually write with a Sharpie what's inside. Keep the bench top dry by wiping up all spilled chemicals. Well, you're going to have drips and things like that when you're moving your wafers from one place to another. So you want to keep those areas clean and dry. You can do it when you're done with that process step, just so no one bumps up against it. You want to aspirate all chemicals when you're done. We'll talk about what aspiration is. Don't adjust any exhaust ventilation. They spend a lot of money getting the whole fab balanced. So the amount of air being, made up and coming in, and the amount of air getting pushed out balances. And so the flow's balanced. If you adjust an exhaust ventilation, then some of the fume hoods won't exhaust enough. And you start to smell things, right? Which is not what you want. There's a photohelic device. It looks like an old galvanometer. It has a needle on it, and it tells you what the atmospheric pressure difference is inside the hood, and it has to be within a certain range, and then the exhaust will be working.
Does that also affect the whether or not the entire clean room is in negative pressure or positive pressure?
Yeah, absolutely. You want to have positive pressure in the clean room. You want it slightly positive. The reason is so there are gaps around the door and around the windows. You want the air coming out of the clean room and not getting sucked into the clean room, because then you're going to suck particles in. So you'll notice that when you open the door, sometimes you can actually feel the air coming at you or pressure difference. Some fabs are even higher pressure. You can even hear whistling. But usually they don't try to make it that high. And if you look at the windows, you can see them bow a little bit because of the positive pressure from the inside.
One comment for your slide here. It says, if the photohelic alarm exhaust is not functioning, then do not use the bench.
Right. Good. Typo on slide 22. Okay. So you want to leave the fab immediately and contact the lab manager so he can fix it, or get someone to fix it. Okay, we have acids. We use hydrofluoric, sulfuric, acetic, nitric, piranha, SC1, SC2, which are super clean mixtures, and also a lot of other non-flammable corrosives. And those corrosives can be acids or bases. But one class of corrosive is an acid. So, those things we use in the clean room, and then when we aspirate, we need to neutralize it before dumping it into Albuquerque's waste stream. Okay. Acids aren't bad if they're neutralized, right? Same thing with caustics. These are bases. Hydroxides are bases. Developer solutions are caustic, and they're also a base. Sodium hydroxide. These are all non-flammable corrosives, but these are all types of materials that will aspirate, and they go into the acid neutralization system. You'll see that in the tour. It's a system that automatically neutralizes the acids and bases as it comes out. There's a pH sensor, and then it'll either add an acid or a base to that to neutralize it. And it has several stages that it does the neutralization over. And once it's within a certain range of being neutral, it's allowed to go into the Albuquerque, storm sewer type waste stream. Okay? But we neutralize everything before we put it in there. And then there are other chemicals like certain solvents that we don't put down the drain, right? You don't put benzene and toluene and that kind of stuff down the drain.
Oh no, it was motor oil and radiator fluid down the toilet.
Yeah, that's not a good thing. Because the whole waste system that cleans up the waste can't handle oil, toluene, benzene. It'll handle organic waste. It'll handle acids and bases to a certain point.
There's this company in town called Rimchem that takes all this stuff and they make it into stuff with product, cleaning product and stuff.
Rimchem, yeah.
And
They pick up our solvent waste.
And I went and took a bunch of motor oil and antifreeze over there, and they're taking this stuff in and they're making a profit off it.
Sometimes.
Well, and this guy wants to know, I need to see your driver's license, I need to see this, I need your address. Who are you? Why do you want my information? What are you gonna do? The hell with it.
Maybe they track it. If you have too much of a certain type of chemical waste, you might be doing a meth lab or something.
They're gonna charge you to flush it.
Yeah. Yeah, I mean, if you're bringing in 70 gallons of fluid a month, you could be stealing it. That's anyway, we digress. You'll see an aspirator. You'll see an aspirator in the clean room. Okay, and that's used. It's a suction device. They use it in operating rooms, right?
Yeah.
They aspirate, fluids out of your body if you're bleeding. They'll aspirate, and the surgeon can see what he's doing. It's the same principle as what you would see in an operating room. It has negative pressure, so it sucks up liquid. We'll talk about how the Venturi works on the next slide. But it sucks up the liquid, and it also mixes it with DI water, okay? Because you use a DI water stream to create the negative pressure in the aspiration tube, okay? So the steps in using it is you turn on the flow. There's a knob here. You turn on the flow of water. It causes negative pressure for the tube that goes, the aspirator tube that goes into the chemical container, so you can lift out the chemical. And then when you've sucked all the chemical out, then you rinse and aspirate the chemical container with water for 3 times to make sure that you rinsed out all the trace chemical. And then you shut off and wipe down the aspirator and the container and return it to its proper place. So this is how an aspirator works. The water enters from the right side, moves to the left. There's a constriction in the pipe where the T is connected. And constriction causes the water to flow faster. You get the same amount of water going in on the right side. Okay, you have a little bit more going out on the left side. But when you have water in a tube that's flowing and then you constrict the tube, the water in the constriction has to move faster, right? Makes sense. Unless the tube starts to balloon out, right? You have constant amount of water coming in as going out. So here we have 2 sources of water coming in. So as the water goes faster, the pressure drops. That's called the Bernoulli principle. That's how planes fly. The air flowing on the top of the wing is flowing faster than the air below it. Creates a negative pressure, causes lift, and your plane can fly. Well, if you do it with a liquid, right, you make the liquid go faster, causes a negative pressure, and then you can suck things up, fluids up. That's how the aspirator works. Everybody gets this wrong on the safety test. You know, how do you aspirate? Okay, so read that part over. Know it well. Okay, but that's the physics behind an aspirator. Corrosives must be stored in a corrosive cabinet. Okay, a corrosive, I think, is something that will cause tissue damage, right? Always use proper personal equipment when working with any chemical. Remember the AAA rule. Always add acid to water. So whatever is more concentrated, you add to the less concentrated valve. So if you're making up a concoction like Piranha, which includes several types of chemicals, you start with the least corrosive first, the lowest concentrated one first, and then you add the more concentrated to it. Okay. The more concentrated one you add to the less concentrated one. So if water is less concentrated than acid, right? So you would start with your water, and then you would add acid to it. Okay? Always add acid to water, or always add bases, to water. When adding several acids or bases, always add the weaker acid or base first, then the stronger one. This is on the test, right? When you're done and you wipe up your little drips, if it contains any kind of corrosive, which is an acid or a base, it goes in the corrosive disposal bin, which is the white bin. Okay, we have different garbage cans. Okay, the white one gets the acid and base rags, the corrosives. Right? Corrosives are acids or bases. The red one gets the flammable ones, the solvents, like acetone. Resist is a flammable, okay, because it has a solvent in it. So that goes in the red bin. The red bin is made out of steel. In case there is a fire, it doesn't leave the bin. And it has a lid on it that shuts real tight. So if it does try to start on fire, there's not, it won't last long. There's no oxygen source. The other, the white bin is plastic. It's really good for acids and bases. Okay, but if you put a solvent in there with an acid and a base, you can get an exothermic reaction and cause a fire. So make sure you know where you're putting your trash. Okay? When you're done using like a developed tray, which is what we're going to use, you want to triple rinse it. If you're done using a bottle, let's say you finish a bottle of material, you don't want to leave a trace corrosive inside of it. So what we do is we'll triple rinse it. So we'll fill it up, a quarter or 10% of the way, shake it, pour it down the drain. Okay. Do it again, do it again, do it 3 times, triple rinse. Wipe off the outside of the bottle after we dump it, and write 3x rinse on the side of the bottle with a Sharpie. That way we know it's empty, that way we know we triple rinsed it. If we don't triple rinse it, then we need, hazardous waste guys to come and pick it up. Right? That gets expensive. If we triple rinse it, then it's clean, and it can go in the regular trash. Okay, don't pour any excessive chemicals back into the stock bottle. You can cross-contaminate it. Now sometimes, we do special experiments and we reuse some chemicals, but it's stated on the bottle that it's a chemical that's been reused, so people know. Solvents and flammables may only be used in the solid and flammable bench. So if you're going to use acetone or you're going to rinse off resist, we do that in the solvent bench, which is a stainless steel bench. The photoresist spin hood is also stainless steel because it has solvent in it, and it's flammable. We don't use use a hot plate on a solvent bench without first removing all the solvents from the work area with flash points within 20 degrees of the hot plate temperature. So most flash points are pretty low. So basically what that means is if you're going to use a hot plate, don't have a bottle of acetone sitting next to it or a bottle of IPA. Okay? There were folks who were using an infrared lamp to heat something up, and they started some acetone on fire. So you got to make sure that you leave your infrared heat sources away from solvents. Okay? So that's just common sense. But if you don't work with chemicals a lot, it may not be common sense. So you keep your solvents away from any hot plates. Don't mix solvents and corrosives. Okay, so an acid or a base mixed with a solvent can cause an exothermic reaction. That's a problem. If you pour both of them down the drain, the pipe's going to explode, right? Not a good idea. Always use personal protective equipment when working with solvents. Okay, safety glasses. Nitrile gloves are okay for most solvents. So if you're using acetone, like when you see me clean the spin coater cup, I will use nitrile gloves usually. If you use latex, well, the latex will actually start to get sticky and fall apart with acetone. Nitrile, not so much. Okay? Or I'll go grab a pair of triple trionic gloves and use that. Okay? Now, Harold prefers us to use triple trionic gloves in cleaning up the photoresist. Probably because it takes a long time and the latex will dissolve. And rather than worry about it, whether or not you're wearing latex or nitrile, it's just better just to use triple trionic gloves. Don't aspirate any flammables. So we can aspirate acids, we can aspirate bases, but we can't aspirate flammables. You don't put a flammable down the drain. You're not supposed to pour your gasoline down the drain, right? But you can pour, you know, drain cleaner down the drain, which is a caustic, right? So we have a container where we pour our solvents and flammables into, and then any rags that we use to clean things with a solvent or flammable contained within that rag, that goes in the red container. When we get rid of the solvents, we can put them in the original bottles as long as we label them as used, but you can't fill the bottle up more than 75%. Why is that?
So that way you don't have to, it doesn't, you don't have a chance, there's less chance of it slopping out the top or.
Well, you put the cap on it. Expansion, right? Gases compress. So if you have, say, you know, 3/4 of a gallon of acetone waste, because you clean something with it in a glass bottle, right? You have 70 or 25% air in there, and now you put it on a loading dock, and the sun's beating down on it, right? It gets hot. It's going to want to expand, but you know you can compress that air on the top. If you fill it all the way up to the brim, it will crack and leak. So that's why we leave some space in there. I always like to tell people why we do things. Now, if you have a rule, especially a safety rule, it's always good to ask, well, why? If you understand why, then you're more likely to remember to follow the rule. If you have no clue why, you may forget the rule, right? At least I'm that way. So whenever we dispose of things, you know, we always let Harold know, and he'll make sure that it gets put in the right place and gets picked up by the right people for incineration. Dispose of the wipes containing flammables in the red flammable waste container only. I know this is long and dreary. When returning chemicals to storage, always store chemicals in the proper location. So we have chemical cabinets for certain chemicals. Place solvents under the solvent bench. No exceptions. So you don't put your acetone over by the, you know, the acid sink. Put corrosives in the corrosive cabinet. That's in the chase. I think they're colored yellow. Never put acetone in a corrosive cabinet because they will react with each other. Never put sulfuric acid in the flammable storage cabinet. So don't mix corrosives and flammables. That's all they're trying to say. And what's a corrosive?
Acidic or base.
Acid or base,
But,
yeah.
But when you're storing a solvent is flammable, right?
Yeah,
Wouldn't that go into the flammables locker?
yeah.
Or did they put it underneath the bench?
That's where we keep it. That's a flammable locker.
Oh, it's a locker.
Yeah, it's all stainless steel underneath the bench. That's why we store it there. They're usually in small bottles, like we have a small bottle of resist, a small bottle of HMDS, a small bottle of acetone, you know, squeeze bottle. So that's where we keep all the little stuff that's solvent oriented. It's under the solvent bench. Okay? Good question. Don't mess with the processed gases. All right, people are specially trained. In fact, when we get a new bottle of gas, we have the gas company that delivers the bottle, changes the bottles. Now at Intel, they train people to do that, and the technicians will actually change the bottles. Changing a bottle of nitrogen isn't that dangerous. Okay, there's still protocol you have to follow. If a little nitrogen leaks, no biggie, right? Air is 70-something% nitrogen.
Saline or
Now,
something.
if the bottle falls over and the top gets knocked off,
You've got a torpedo.
you have a torpedo, and it will go through a cinder block wall. So, you know, you still have to be trained on how to handle gas bottles. You'll see all the gas bottles that are benign, like the oxygen, the helium, and the nitrogen. You'll see them in the clean room when you take your tour, but they're all in a stand. They have a chain around them just to keep them from falling over. Okay? The stuff that's dangerous, the methane, the silane, and I don't know what else we've got now, is outside in a chemical gas bunker. So the silane can burn in that bunker in the cabinet for 4 hours, and then the bunker lasts another 8 hours before everything melts down, right? So those chemical bunkers and cabinets are designed to contain a fire for a long time. All right. So basically, don't mess with the tanks. You know, high pressure gases, even the ones that aren't dangerous by themselves, the high pressure is dangerous, and it's cold, right? Expanding gas is very cold. You can actually freeze your fingers, you know, if you have nitrogen coming out of the tank at high expansion rate. The other thing I want to point out, there's a lot of chemical lines, gas lines. They look like silver pipes. Okay, they're actually stainless steel pipes. There's a specialty type of weld that they use. If you ever do welding, if you get certified in doing stainless steel gas pipe welding, you're worth a lot more money. You get paid more to do that. But it's a very unique skill to have. But those pipes, you don't want to lean against them. Okay, don't lean against the wall. Always know what's around you. Okay, we had a engineer that was an equipment engineer at Texas Instruments. He was taller, probably 6.5 feet tall, and he liked to lean against the steppers, the machines. Well, a certain class of steppers we had, they put their emergency off button up here.
Oops.
Right? And the reason is so you don't bump into it. But it's still there, you can hit it with your hand.
Against it?
Well, he would lean against it and put his head back, and he'd turn off a stepper. Okay, well, you shut down a piece of equipment, you'd think no big deal. It took us like 4 days to bring the equipment back up, because it's like you're running a software routine on your computer and someone just pulls the plug. You can crash and burn a computer pretty well doing that, right? Imagine a $10 million machine and you pull the plug on it. Now those emergency off buttons are there for a reason, that somebody's getting electrocuted, right? You hit it, it turns the power off to the entire machine. That's usually why people hit those things. sometimes your hand gets caught and you're being pulled into a machine, you'll hit that. The problem with when your hand gets caught into a machine and you hit that button, sometimes whatever what's holding you stays shut. You need to apply power to open it again. So the newer machines are built in such a way that if power is off, everything becomes loose. So it doesn't grab hold of you. All right? So be aware of the piping and the emergency off buttons and what's around you. Try not to lean against anything. Okay? Always wear the right personal protective equipment whenever you're dealing with stuff. Okay, the safety shower looks like this. You'll see it in the clean room. There's a triangular handle you can pull on and all the water will come rushing out. It's regular city water, very cold. We want cold water. Why do you think we want cold water?
Slows down the reaction.
Slows down the reaction, good. Why else?
It's burning.
Cools you, cools it down. It's burning. Why else?
Holds more of the concentration. Hot water doesn't hold concentration as well.
Yeah, some people would argue warm water would actually be better to rinse off with than cold water. But the thing with cold water is what happens to your pores?
Close up.
They close up. You don't want more chemicals going through your skin, right? So by dousing you with very cold water, all your pores close up, and then the amount of chemical that gets absorbed by your body goes way down. Okay, we also have eye washes. They look like this. Kind of like a water fountain. They have little caps on them. You just pull the caps off. Usually you have to help a person because if they've got stuff in their eyes, they can't see. So you bring them over to there, pull the caps off, dunk their head in and push this lever down, and you'll have a shower of water going through the eyes. You know, and you do that until emergency help comes. And then they have certain, you know, things they can put in your eye to stop the reaction if it's still going on. And try to keep your eyes open. Hold them open. It doesn't do you any good if your eyes are shut and you're trying to rinse that chemical out. These are some of the emergency kits we have. Here's the AED, the automatic defibrillator. We have a CPR pack. Okay, so you can bag a person if you know how to do that. I haven't had training in decades, so I probably should go do that sometime. And then we have our general first aid kit for cuts, you know, scrapes, things like that. And we also have a calcium gluconate salve for hydrofluoric burns. Okay, this is your carbon dioxide suppression tank. It's a big tank just filled with CO2. Okay, if that goes off, of course, we leave. We go to Basehard and Bradbury. That's where we assemble, do our head count, and find out what happened. You know, the CO2 suppression system floods the clean room as well as the service chases with carbon dioxide. So if you breathe too much carbon dioxide, it is bad for you. Harold actually, when he gives the safety lecture, he talks about, he actually has a degree in zoology, I think. A master's in zoology. And they had to do an experiment where they got a dog and they overdosed the dog on CO2 and then tried to revive it. So they would learn the chemistry. So if you have too much CO2, I think it makes you stop breathing. And it's really hard to get started again. It's not just that you pass out, it does other things to you. But he'll tell you more about that. So it's not just that the absence of oxygen, like when you flood in a room with nitrogen, it also does, too much CO2 will mess with your brain and cause other functions to shut down. Okay, go to Bracehart and Bradbury. So we keep saying that over and over and over again, right? That's important. Don't leave the scene. It's important. At Texas Instruments, you know, we have practice drills, and one time 2 guys decided to go to Burger King. Right? So they weren't at the assembly point. We didn't count them. They got fired.
Good.
That's how important it is. Okay? They were fired on the spot. They came back with their bags of, oh, well, we thought, well, you thought that was a problem. Okay, this is the schematic of the clean room. Okay, we're going to be working in this bay here. There's multiple bays. We'll come in here. This layout is a little old. We now have a change room here. Okay, so we come in here, we put on our smock and all of that, and we go into the clean room, do our work. If there's an emergency, we can go out this door, and go out this door, go to the assembly point. We'll point that out at the tour. If this is blocked or not available, you can go out the back way through the loading dock and go to the assembly point. And you'll see all of this when we take our tour. Okay, so just get familiar with the general idea. North is up. This is where all the air handling units are outside. This is like a wall around it. It's not actually a room. This is outside the building. So when we take our tour, you'll see this as well. Okay, so you can go out this door and get out. And if for some weird reason these are blocked, then you can go out here and actually go out the other way. But you still want to go around the building to the assembly point so we can find you. Unless, you know, the assembly point's flaming. You know, you don't want to be standing there. Don't answer your phone without first rinsing and drying your gloves, then going into the gowning room to answer the phone. Remember to replace your gloves with clean gloves. Never touch common items such as door handles without first washing and drying your gloves. This will keep chemical contamination from spreading in the fab. And if you're in acid gear, you don't touch anything. Okay? You don't go out of the door wearing your acid gear. There was a vendor company that used the clean room. One of the technicians would take the wafers from one bay to another with acid gear on. That technician was told once and then twice not to do that. Ignored Harold, and Harold barred that technician from the clean room until the company promised that won't happen again. Okay? Buddy system, always have a lab partner. Okay? Help each other out, know the evacuation routes. So if you see something, yell out, get everybody out. Okay, this deals mostly with people who are using the clean room kind of on their own. I mean, there has to be another person around. But only use equipment you've been trained on and qualified for. Okay, and Harold will tell you if you're qualified or not. Now, we'll have you do some things in the clean room, but we're standing there telling you what to do. Push this button, watch out for that, and we're there to hit the off button in case something goes weird. Okay? Because we do want you to do something in the clean room, not just observe. Don't attempt to fix anything on your own. Okay? Shut off facilities if it's unsafe. If anything breaks, tell Harold, right? Leave a note if he's not there immediately. Leave a note. Don't use this machine. Something's not working. Explain what it is. Don't lean or bump equipment or auxiliary equipment. I want to stress this a lot. Be careful what you lean against. Be aware of the emergency off system buttons. If you accidentally think you may have bumped one, tell Harold. Right? Machines don't like to be off a vacuum for a long time. They don't like to be shut down for a long time. If you think you might have bumped a button, tell Harold. We'll go check it out.
So that way he can take you outside the room, clean room, before he kills you?
No, he won't kill you. I mean, he'll appreciate that you told him. Because we had that happen in one of our workshops. Were you there? I don't remember. Someone may have bumped the off button on the deep reactive ion etcher, which is a $600,000 tool.
Wasn't me.
And it was no. We don't know who it was, but you know, there's lots of reasons it happened. It could have happened, but the person who bumped it probably didn't even know they bumped it, or they didn't know it was important. You know, they didn't hear any alarms go off. But now that's why we put that in here. So if you think you might have done something or switched something on or off, let us know. And we'll check it out and see if it's an issue or not. And maybe we can keep the equipment from having to spend $20,000 to fix it. So these EMO buttons, emergency machine off buttons, EMO, that's what they look like. They're red with a yellow frame around them, most of them. Okay? Some of them have an acrylic shield around it to keep people from accidentally turning them off. You know, these tools are used a lot. They're opened and closed. Buttons are pushed all the time. So they put a little shield around it. You can still turn it off by hitting it pretty easily. Some people don't like these. They think you should be able to turn them off if you just get close to them, you know, and not have to do this. And, you know, for safety reasons, I can understand that argument too. So some of them are just out in free space. So be careful, right? You lean against that, it goes off. Look where they conveniently put this one.
Yeah.
Look at the chair height. This is the one that was accidentally turned off.
That's awesome.
Okay? So I went in the fab and, you know, because Harold had said, you know, who in the workshop turned off this tool? You know, I don't know. I wasn't even in that bay. You were in that bay. You know, this is the bay with the evaporator. And I go, I don't know. So I don't even know where the EMO button is on that tool. So I went in and I found it, and I see the chair there, and I see the EMO button. I go, well, I could kind of guess what might have happened. And I took a picture of it. So we're probably, you know, we talked about putting some kind of, you know, ring around it or something like that to make it less likely to turn it off with a chair. You know, we're all busy. I don't know if we actually fix that, but you can see that could be an issue. More rules. Okay, dispose of waste in the proper location, corrosive, contaminated materials, wipes, acid gloves, etc. into the what container? White. That's on the test several times. Acid and caustic waste are considered corrosives. Their waste should go in the white containers. Okay, we're repeating ourselves. Flammables go where? Red. Right, that's easy to remember. Solid and organic waste go in the red flammable waste cans. Okay. Regular non-contaminated waste like paper, pens, plastic bags, you know, stuff, general trash, goes in the general trash containers. And we have a stainless steel looking one, you know, the one you step on and they flip open.
Yep.
Regular trash can go in that, and then there are these brown plastic ones out in the hallways and stuff. Regular trash. Sharps. What are sharps?
Razor blades, wafer pieces.
Razor blades and wafer pieces are really sharp, like the ones we had over there. They go in the white and red containers. And there's one on the wall, I think. It's kind of high up. Usually I put a hypodermic needle picture next to it, because that's what most doctors' offices use sharp containers for. And it's a special container, so that you just throw the whole container out and you don't cut yourself.
Biohazard ones?
We don't have biohazard containers.
But that's the same, it's the same kind of thing? Like
Same kind of thing.
They'll have them in the, I used to work in Sleda, and in the restrooms they have these, you know, one of those little things for people with diabetics.
Yep.
With needles.
Yeah, biohazard, yeah.
And they just pull the whole box out and change
Yeah, it's nice. It's a really nice thing that they do that. So regular trash, flammables, it says flammables only. Okay, acid waste rags, but you can put bases in here too. It's corrosives. And we call it acid because it's by the acid sink.
Doesn't that create a burn hazard when you mix the caustic with the base?
No.
Caustic with
No, they neutralize.
No, they neutralize each other. If a flammable with a caustic will have a because all an acid and a base is in the case of an acid, what, you get H ions?
Yep.
And in the case of a base, you get OH, and when you combine them, you get water.
Yeah, I thought it was going to make a reaction.
I don't think so.
Well, yeah, with neutralization reaction.
Well, it's not flammable. It doesn't start on fire though. It's not enough.
Okay.
It might be exothermic. It may get a little warm. I don't know. It's not my expertise.
Yes.
This is really important. You've all seen these, right? What do you see these signs on?
Everything.
Just about everything. You're driving down the street, you're behind a gasoline truck.
Yep.
It's got this on it, right?
Well, it's just got the diamond part on it.
This diamond here is probably a 4 or something with gasoline, right? Very flammable. So the higher the number, the worse it is. So red is flammable stuff. So if you have a number in the red zone, that means it's flammable. If you have a high number in the red zone, it's really flammable. Blue is for health. Got to know these colors, okay? It's on the test. Blue is for health. The way Harold reminds us to remember that color is, what color do your lips turn when you're dying? You turn blue, right? When you're dying. So that's why it's blue.
He sounds like a cool guy.
Hey, he's a good guy. I like Harold. Very serious, which is a good thing. So, 4 is bad. 0 means water might be a 0 for health. Now, if you hold someone's head underwater, it becomes very hazardous, right? But by itself, it doesn't hurt you.
If you drink enough water, it'll kill you.
Yeah, sure. If you drink enough of anything, it'll kill you, including water. Okay, so you got yellow is for reactivity. So how reactive is this stuff? Okay? And then white is for special instructions. Okay, so water with, or W with a line through it says don't use water. This is important for firemen, right?
Yep.
What do they usually use? Water. If they come up to a truck on this side with all this chemical leaking out, they look at, the first thing they do is they look at the NFPA diamond, okay? And then they see the W with the line through it, they know not to use water. So they use foam or something else. Okay, some of the trucks you'll see have radioactive stickers on it, right? Especially in New Mexico, we're taking stuff down in the whip every once in a while. You see that. Or if it's corrosive. Okay, so now they know how to fight the fire or clean it up, at least to some degree. They know what the dangers are. If you have a 4, right, and the truck's on its side on the highway and it has a 4 on it, it may blow up. So the first thing they're going to do is get everybody as far away as possible. And then they'll send in someone who can gauge how unsafe it is. So yellow is for reactivity, red is for, blue is for, white is for special instructions. Cool. We're OSHA compliant. We actually have more safety stuff at the clean room than we're required to have. Okay? Most, the OSHA generally covers industry. They don't usually cover university labs. That's why a lot of university labs are kind of cagey on their safety. But we have OSHA type compliance inspections from the state that come into the university labs. Okay? So we're actually safer than some other states.
Actually, that would be, Harold's an employee there, so he would be covered under OSHA, wouldn't he?
I don't know, but I know that OSHA generally doesn't deal with labs, chemical labs and stuff at universities, because they're self-insured and all of that. Anyway, it doesn't matter. OSHA stands for Occupational Safety Health Administration. All right, always wear the correct PPE, report unsafe work conditions or work habits immediately to the lab manager. If there's someone you're working with that keeps taking their wafers and holding them in their hand and dipping them in the sulfuric, and you say, hey, you're not supposed to do that, there's a carrier for that, and they say, bug off.
Well,
then you just tell the lab manager, because if someone gets hurt there, they got to shut the lab down, do an investigation. It doesn't just affect that one person, it affects everyone. Plus he's getting chemicals all over the equipment, right? Yeah. So report it. The first thing you do is you let people know they're doing something unsafe, and if they ignore you, then you tell someone else. And watch out for each other. They may be doing something out of ignorance. So, everybody's responsibility is safety. Any questions? Wow, 3-hour lecture. Good thing I didn't want to do the design lecture today too. I'll just post that one. Okay. Take a break, come back, we'll play with some wafers. We're going to handle some wafers. You're going to learn how to handle wafers properly. So we think that's better to learn outside of the clean room than in the clean room.